So this is the presentation on graphing special functions, and we're going to start with flashcard number 41 that we set up in class. And under the column that says to graph any function, we're going to talk about how to do this. So special functions are going to be ones that we haven't graphed before and ones that really are kind of tricky to graph. So the best way to do this is always to use your calculator. So this will work for any function. We do know some tricks for certain types of functions to help us graph them. But for any function that you need to graph, you can always use this method. So if you graph it in your calculator, which you open a new document and create a graph, you're then going to use the table to plot all points that fit on the graph. That's everything from the negatives to the positives and everything in between that you can fit on your graph. You have to plot all of those points. Now remember, in order to use a table, you have to have put it in as a function. Otherwise, you'll have to use trace. Okay, so keep that in mind. Once you've plotted all of the points that fit on your graph, then the tricky part is actually drawing the graph. So you're going to use the graph on the calculator to help you draw your graph as best as possible. And a little note on that one is that sometimes you have maximums and minimums, and you can find those points using the menu and analyze graph on the calculator. So that's a great strategy as well if you have maximums or minimums to help you find those points as well, especially if those points are not given in the table. Okay, once you've graphed the given graph, you want to make sure you have arrows and a label on the graph. Okay, so we're going to focus on three different types today. Okay, for this presentation, we're going to focus on step, absolute value, and piecewise. We're also going to look at different situations like square root graphs, cube root graphs, cubic graphs, and even maybe some other things that we really haven't seen a lot before. But these three are the three we're really going to look at for this presentation, just so I can kind of show you what I mean about using the calculator to help you. Now notice the step function and the piecewise function have open circles in them. Your calculator cannot give you those open circles. It doesn't give you where those open circles are on your table or on the graph itself. So you need to know that those are going to be there, and you're going to need to know how to plot them. Okay, so that part can be a little bit tricky. So let's start with the step function. The step function is created by what we call a greatest integer function, which is this right here, where you have the brackets around the x, and the brackets around the x indicate that we're looking for the greatest integer, which means that all of our decimal numbers end up turning into integer numbers while they're being graphed, which is exactly why we have what looks like steps over here. Okay, because every decimal turns into a whole number or an integer, so it can be negative. Okay, the domain here is all real numbers. You can plug in anything you want for x, but in your range you only end up with integers as answers. Notice we have open circles, okay, on these steps on the right hand side, so I want you to keep that in mind as we work through this. Okay, so if we're asked to graph this greatest integer function, x minus 2, and we're going to state the domain and range. So first you're going to make a table, which you're going to use your calculator to do that. And then on your graph, you want to make sure that you have closed circles at those points at your table, and then we'll have open circles for the points that are not included. Now this is what the table would look like if you included decimals. The table on your calculator does not automatically include things like the 0.5s that we have on this table, but just so you know, to get the greatest integer function, this is how it works. So let's look at negative 2.5. Negative 2.5 minus 2, which is what the function tells us to do, x minus 2 gives us negative 4.5, but that is not allowed to be a decimal, so it goes to the integer negative 5. Okay, so notice that any of these decimals, negative 3.5 goes to the integer negative 4, and negative 0.5 goes to the integer negative 1. So when you end up plotting this, this is what it looks like. Now your table on your calculator will only give you these solid circles, and then the calculator will show you the steps, and you have to do the rest. You have to know to draw the steps in the open circles. I'll show you what that's going to look like, but let's talk about the domain and range first. So the domain here from left to right, notice that the graph, it actually goes like all the way from the left up here, and then when we have an open circle, it jumps up and has a closed circle. So every single x value is actually included in this. So we can say that the domain is all real numbers, or negative infinity to infinity, because these steps would keep going. Okay, the range, however, is only the integers, because notice for the y values we have -5, and then we jump up to -4, -3, -2, and so the range is only integers. Okay, so this is what this looks like on your calculator. First of all, you need to know this right here. You only type in int. You can't type in the brackets, it won't work. So you're going to type int for integer function of x, or you can type in whatever that one previously was x plus 2. So you can type in whatever they give you. And this is what it looks like. So they give you the steps, but they don't give you the open circles. So you need to know that you have to draw an open circle on the ends of each of these steps. Okay, so here's what the table looks like. It actually looks like a linear function. 1, 1, 2, 2, 3, 3. That looks like a linear function with a slope of 1. But then you use the graph to help you figure out that you need to actually draw in those steps. Okay, and that's what that ends up looking like after you graph it. You plot the points and then draw the steps and draw the open circles. Okay, here we have another one. And I just wanted to talk real quick about the domain and range. For this one, notice that the steps are in a different spot, but the domain and range are actually still the same. The domain is all real numbers, and the range is all integers. So that will be the same for every step function. Okay, we're going to actually skip this real life problem because I want to have enough time. So we'll go over a couple of those in class. But there you go again with another step function. So I want you to take a couple minutes, 1 or 2 minutes, to write notes in the notes section of your flashcard about step functions. Okay, don't use a whole heck of a lot of room because we're going to talk about different kinds of functions. Just make a couple of notes. You can draw a picture of what it looks like. You can describe what it looks like. How do you graph it? Which button do you type in on the calculator? And what else might you need to remember? Okay, so you can pause the video and do that. And now we'll move on to absolute value functions. Absolute value is a v, and just like a parabola, it has a minimum point or a maximum point if it's upside down. So I want you to keep that in mind because you can find the minimum or maximum on the calculator. So here's an absolute value function, 2x plus 2. It's in the table right here, the absolute value of 2x plus 2. This is what the table would look like on your calculator. I'm going to show you what your calculator would look like in a second. And when you plot all of those points, you need to recognize that it's a V shape, so you're going to plot that with straight lines on either side. The one thing I want you to recognize right here is that we have this minimum point right here where we have symmetry on either side. We have those matching values, so it would be very beneficial to always find that minimum point before you do anything else. Okay, but always plot all the points you can fit. In this case, the domain is all real numbers from left to right. We go arrow to arrow, negative infinity to positive infinity. The range is all non-negative numbers, which means positive, 0 and positive. So the range goes from 0 to infinity. So you could write it like that instead. This is what it looks like on your calculator. This is what it looks like with the table. Again, notice you've got that middle point. That's your minimum, but we can do menu, analyze graph to get the minimum. So that's always an option too, so that we know where that point is. And so you would just plot all the points you can fit. Remember, you can scroll up and down in this table. So plot all the points you can fit and graph it. Okay, so that was a quick overview of absolute value. So pause the video again and write yourself a couple of notes on your flashcard about absolute value. What does it look like? How do you graph it? What button do you use on the calculator? And what else should you remember? And last, we're going to talk about piecewise functions. Piecewise functions are defined by pieces of 2 or more functions. Okay, so we're going to go through this one pretty quick as well. So notice here that this is the graph of negative x if x is less than 0, and it's negative x plus 2 if x is greater than or equal to 0. You really need to think of like graphing each of these in full and then having scissors and cutting at 0. And if you cut it off at 0, you'd have this graph only on the left because it's to the less than 0. And this graph you would have to the right because it's greater than 0. Okay, the one thing you have to know is that you put an open circle on the graph where there is an inequality symbol like this one without the equal to part. Okay, so what I do is I plug in 0 here, and I get an answer of 0, which means there's an open circle at 0, 0. Okay, so you plug in this number, get an answer, and the open circle is at that coordinates. Then you can graph each of the expressions. Your calculator will give you every other point. Your calculator won't give you the open circle, but it will give you every other point. So take a look here on your calculator. By the way, right here is your absolute value if you didn't remember that. But here is where the piecewise is. This is the button next to the book, and it's the one that has all the symbols on it. Okay, so the piecewise function is this one, the bracket with the boxes and the commas. And if you have 3 pieces, you would choose this one. We had 2, so I chose that one. You type it in just like this, so you need your inequality symbols to type those in, and then you graph it. So notice we have 2 lines. They do get cut off at x equals 0, but there is an open circle at 0, 0, and it doesn't show that on here. It also does not show the coordinates 0, 0. It shows 0, 2, because that's part of the other line. So you need to know that there's an open circle at this spot and a closed circle at this spot. Okay, so we'll continue to work with that in class, but otherwise you just plot all the other points and graph it using the calculator. Okay, and that's what it looks like in the end, with an open circle here and a closed circle here. And this graph has a domain of all real numbers, so negative infinity to infinity, and a range of all real numbers, negative infinity to infinity. That's not always true for piecewise, so you have to use the graph to answer domain and range. Okay, so we're going to skip this one. Sorry about that, because I want to have you write down your notes. So take 1 to 2 minutes to write notes to yourself about graphing piecewise functions. Do that in the notes section of your flashcard. We will take a couple other notes next class just on a couple different other kinds of functions, but I just want you to remember the most important thing is to use the calculator to plot all the points that you can possibly fit on the graph. Okay, and so these were the 3 functions we covered today: step, absolute value, and piecewise. So if you didn't get a chance to jot pictures of those on your notes, go ahead and do that now. And as long as you have written down notes about those 3 types of functions, then you are all set and done with the video, and I will see you next class.